Welcome to class number 80. As I told last time, this question with uniformly varying load, 0 at left end, maximum at right end, with 1 point load anywhere in the span. This is a third question or last question. In between, I will explain the three different problems. Total 3 problems we have solved. Not we have solved, 2 we already solved, 1 we are solving now. See, last time I told load is 60 kN at 4 meter. Hope some already solved it and got the answer. You can check it now. See, I maintained the same question little earlier. Last class, actually earlier because little earlier when I finished recording, but for you last class. See, let VA be reactions. I removed that 200. I placed 60 kN. Don't see here now. 60 kN. Take moment about A. Last time it was 200. Now it is 60. Reaction will get same as last time. Change is instead of what was last time 200, now replaced by 60. Okay, reactions came. Also, you require intensity here. 30 by 10 equal to this side by 4 or directly 30 by 10 into 4. You get 12 kN per meter. See, I entered the new reactions here. Now, go for shear force calculation. See, shear force at A plus 86. Shear force just to left of C. The answer is plus 86 minus this much load, half into 4 into 12. Now the value will change. Equal to, I'll calculate now. In between, I will tell you the difference between the 3 questions. 86 minus half into 4 into 12 will give you plus 62 kilonewton. See, plus 62 kilonewton. Then, shear force just to right of this one. So this is 60 kilonewton. See, I forgot to change it now. Just to write equal to same as that previous answer, plus 62 minus 60 equal to plus 2 kilonewton. Okay. Now, shear force at B, it is plus 2 minus 12 plus 30 divided by 2 into 6. It will give you 2 minus 12 plus 30 divided by 2 into 6 will give you minus 124 kilonewton. Okay, see. Now, shear force variation is parabolic from A to C and C to B. Same statement last time. Right here, go back and draw the shearing force diagram. This all I told last time, shearing force diagram. Okay, 1 minute now. 1 minute. This all will change now because this will change. Okay, now. Go back and draw shear force diagram for this case. The BMD also will change because changes will come now. When you draw shearing force diagram here, see, go up by 86. 86. Just to left of C, shear force is plus 62. Again, here, intensity is 0, 0 slope here. It will come this way, see, 62. Parabolic of second degree. Then, this is how much? 86 minus, already got the answer, 62, positive 62. Come down by 60. A small value is still there, that is 2, out of scale. Okay, now, from this point, again parabolic. As I told you, what slope is there, same slope you have to maintain. And when you reach here, it will be 124 negative. That much will not come actually. It will come very nearby. Okay. The change point will come. Okay. Reasonably okay. The same slope here. This is 124. Go up by 124. These all already over so many times. So I should not explain again and again. Those who follow correctly, they will understand. This is a shear force diagram. Okay, now go back and draw the shear force diagram. This statement I am telling right from beginning. Observe the shear force diagram and check whether any point is there where SFD either crosses baseline or suddenly crosses baseline. Yes, last time it was crossing the baseline at C. Now somewhere here. So answer should be yes. There is a point here. See, there is a point here where shear force diagram will cross the baseline. Now, we want to locate this point. Don't actually, you can write here only, but I will write separately here. See, next. location of the point, location of point where after C, between C and B, between C and B, where shear force equal to 0. Next, let why you had to locate this, all I told, write the statement, that is the point where bending moment is going to be maximum, all same statement. Let shear force be 0 at a point x, comma, at x from where? This is important now. See, now important. If I take x from here, see, if I take x from here, then this will become x. Then you get one triangle here and trapezium here. So you should think a little how to solve. Instead of, then there will be difficulty for calculations. Little lengthy calculation will come. See, we want a point here after C where shear force is 0. If you look this side full, you get a triangle. Therefore, you take x from A. Later you get this distance, x from A. Next, let W suffix x be intensity of UVL, intensity of UVL at the point x. So therefore, you better draw one diagram here. See, to understand correctly, draw a diagram. This reaction is 86 kilonewton. This reaction you don't require now. This is how much? 30 kilonewton per meter. This is A. This is B. This is the valuation. Somewhere here is the point C, where there is a point load of 60 kilonewton. Our point X is somewhere here. X here. We are taking X from here. We are taking x from here. Now, this intensity we are going to write. I write somewhere. I shift 30 this side. I will put 30 kN per meter here because I can make entry here. This will be W suffix x. Okay, leave it. First get W suffix x equal to 30 by 10 into x. 10 into x. Or equal to 3x kilonewton per meter. Okay. I'll enter here equal to 3 times x kilonewton per meter. Now, shear force at x equal to, now you can write a statement. Now you are locating the point x by equating shear force at x to 0. So shear force at x, look this side, plus 86 minus this much load. See, this much load is half into x into 3x minus half into x into 3x. Not over, see, not over. This force minus this total load also minus 60 equate to 0. So you get half into x into 3x is 1.5 x square. Take other side, you get 1.5 x square equal to 86 minus 60 is plus 26. Therefore, you get the value of x. I think last time I told you about x value. 26 divided by 1.5 equal to root answer. I remember same answer. 4.1633319999 is coming. I write for fourth decimal 1633 meter for accuracy. Okay, now little more work. Substituting this x, we get, substituting x, you get intensity at x equal to, this you require for BM calculation. How much? 3x. 3 into 4.1633, actually red color, okay, no problem, equal to 4.1633 into 3 will give you 12.4 4899 or 12.49. It will be 12.49 kilonewton per meter. Just check the answer once again. That is, how much it is? 3 into 4.1633. Okay, 12.49 kN per meter. Right here, go back and enter. And enter here. Or equal to, how much I got? 12.49 kN per meter. Okay, now almost everything is ready. Now lastly, go for BM calculation. I'll do one thing now. All this I'll remove now. See, the shear force calculation also I'll remove because I want space for BM calculation. I hope when I entered here, nothing mistake from last time. Sometime it happens that I might have forgot to change a value, change it then. In that case, this diagram is still required. See, and this also not required. I can remove this one. This also not required. Even all these are not required. But okay, start. Lastly, I will explain the 3 questions once again for you. Okay, now lastly, I'll go for here BM calculation. Sagging positive. Bending moment at A equal to 0. Then you require bending moment at C equal to, look this side, plus 86 into 4 minus moment of this much load. Half into 4 into intensity is, how much it is? 30. It is 30 here. This is 12, I think. Yes, 12. Half into 4 into 12 is the total load into 1/3 of 4. I should not explain this one because explained many times. So 86 into 4 minus half into 4 into 12 into 4 by 3 will give you 312 plus 312 kN meter. Then BM at B equal to 0. Also, see once again, you require BM at A, BM at B, BM at C standard point, and also you require BM at the point X. Also BM at X. You can write a note, that is the point where bending moment is going to be maximum. Also BM at X equal to, use this diagram, see, plus 8, you can enter all the values here. X also you got how much? Enter everything. I forgot the value of X, so now 4 point, I can check other way, 12.49 divided by 3, 4.1633. This is the other way of checking answer. Okay, now calculate equal to plus 86 into 4.1633. See correctly here now. Very carefully find bending moment here. Here bending moment. Plus 86 into 4.1633 minus moment of this much load. So minus half into base is 4.1633 into height is 12.49 is the total load multiplied by 1/3 of this distance, that is 1/3 of 4.1633. Close the bracket. Not over. Also minus 60 into this distance. 60 into, this is 4.1633. This is 4 meter. That much you can calculate 0.1633. You can write if you want. This 60 into this distance. 4.1633 minus 4 equal to 0.163. Answer will come 86 into 4.1633 minus half into 4.1633 into 12.49 into 4.1633 divided by 3 minus 60 into 0.1633 equal to plus 312.16 kilonewton meter. Let it be red color. Okay, this is the maximum bending moment. Okay, now last part. What you write? BM, you one thing you can write yourself only. BM variation is parabolic of third degree for AC and CB. Okay. Now go back and draw bending moment diagram. Start. Here baseline is there for bending moment. See, at this point 0, at this point 0, at this, now you should do one thing. You should locate that point from here to here. Write the distance here, whatever you got. 4.1633 meter. This is 4 slightly after this point. Okay, now at this point C, see, at the point C, BM is how much? At C, 312. 312. That is not the maximum BM. The space problem here. I'll put here 312 is the BM at this point. Okay. Then at this point BM is slightly more, very minutely more. How much it is? 312.16. Now here to here is one parabola. See, and that parabola will have slope of 86 here and 62 here. So it will come this way. Here slope is 86, here slope is 62. Then from here to here, one more parabola, cubic curve, but how? It will have little lesser slope. See, how much slope is there? The slope should be little lesser here. See, that is, see, little lesser. And it will touch the higher value. So I should slightly increase this one now. Because the problem is here, such a small value difficult. Okay. Then it will slightly increase, and then here slope should be 0. It will come here and join here. See, this will be, here the tangent will give 0 slope. Here slope will be 124. Exact scale not possible. So here 0, here 0, at this point 312, at 0.163 meter, it will become slightly more. See here, see from here to here, it will become slightly more, then drop. And this is the point where shear force is 0, therefore slope for the BMD there should be 0 or tangent should be horizontal. So draw the bending moment diagram. I think everything will be clear now, this question. I hope that when I remove the last time values and put a new value, nowhere something is skipped or previous value remains. I will check once again. If it is not a major one, you change it. Okay, now this will give bending moment diagram. Now I will just explain all these 3 questions once for all, once again for you. 1 minute. Okay. See, all I will remove now. I will tell you why the 3 questions are solved. So those who are serious and want to understand, they can learn lot of concepts by these 3 questions. Actually, such questions are already solved earlier also with UDI and point load. So, but still better to understand. See, roughly, I will explain here. See, our first question was this way. How much numerical I am not putting. A load was somewhere near to the support. Second question, which is solved last class, was a very heavy load here. I will put heavy load. Question just now we solved. It's a light load here. See, what happened is, here shear force diagram, shear force diagram, shear force diagram, scale I am not maintaining. It will come up here. Then when you reach here, see, it will come this way. It came this way. So the shear force will come somewhere here. So when you draw BMD, this is the point of maximum BM. Maximum BM here. Next. Second question, sufficient. You see the diagram. Second question, your shear force diagram came this way. Shear force diagram crosses baseline exactly at the point load. Here BM, it will come this way and this way. Different slope either side. See, this is the maximum value. But see, here at the maximum BM, slope is 0 because shear force 0. Here slope is not 0 because either side shear force is there, or this maximum BM is at the point where SFD suddenly changes sign. So if it suddenly changes sign, then slope will not be 0. If it is perfectly 0 shear force, then only slope will be 0. And this question, shear force diagram came this way. It crossed the baseline somewhere here. So here we got maximum BM. See, I put only BM here. Maximum BM came here. So that's the reason we solved 3 questions. All 3 questions solved once again. Next class what I will do is, class number 81, I will solve the same 3 questions. But remember, I will not talk much. UVL I will place like this. This way I will place. And again 3 cases I will solve. See, I will put a point load here. Once SFD will cross the baseline between these 2 points. Once SFD will cross the baseline at this point. Once it will cross the baseline here. So same as this one, 3 more problems for homework or practice purpose. Only change is now a triangle is from this side. So you should do calculation for bending moment all from right side. And when you locate the point X, you consider X from right side. So that all I will tell next time briefly, but too much I will not explain because same as the previous question. So you solve it. Okay. Thank you. We will meet in class number 81.